This is a Xenon data beam analysis for Will Hibbs, pitching, collected in July 2012. We look at the performance profile. First thing that jumps out is an arm speed that's pretty high, well above our average, which would indicate potentially good ball speed. However, we do see, or release velocity, but we do see a fairly low internal rotation speed. So even though we have a high arm speed, internal rotation speed being on the low end, we know there's probably some biomechanical breakdown or inefficiency in the pitching motion. And so you got to look at arm speed doesn't always translate into ball velocity. It's not a one-to-one relationship, depending on how that speed is being developed, the release dynamics, and so on and so forth. So that would indicate not only we see hip segment quite a bit off, almost a little more than half what we would expect, and shoulder segment pretty high. We know there's some biomechanical inefficiencies going on. So when we look at the kinetic link, we're now looking at the speed generation process, really from the ground up. So what we're looking at here is rotational speed output of the hips, then the shoulders. Then we look at, as we go in the ball release, the rotational speed output of elbow extension followed by internal rotation velocity at the shoulder, which is what really facilitates acceleration. And what we see in the kinetic link here, foot contact, ball release, is that we have upper body dominated throwing pattern and very little lower body contribution. As a result, we have a pretty big gap between peak shoulder and arm acceleration. And what we end up getting is a lot of elbow extension speed and less internal rotation speed. So you can kind of see here, now you see some internal rotation speed late, but if you look here, what we have is very upper body dominated process. The legs are not driving that power process. So now we're going to get some flinging forward, and you'll see the elbow extending towards ball release rather than the arm internally rotating. So we're putting a lot of stress on the shoulder and the medial aspect elbow, in particular medial aspect elbow, but also on the shoulder, as a function of really generating speed by sort of pushing the elbow forward and extending the arm at the elbow rather than internally rotating at the shoulder. So although we have high arm speed, the generation of that speed and the delivery of that speed with respect to ball acceleration out of the hand has issue. Now we'll look at lower body mechanics. When we first look at stability, we're looking at a couple different key areas. First, stride length and direction. Stride length is good, right where we would expect it to be. Direction is good, right where we would expect it to be. And we can also see that Will lands on his foot, which is great, not his heel or his toe. So he's landing on his foot. However, he comes in at about 50 degrees of forward flexion, or knee flexion, which is great, but then extends quite a bit. So we see him now stiffen that front leg as opposed to maintaining that stability. Although it looks pretty decent, we can see him going to some extension. We don't see good translation of ground reaction force in the lead hip acceleration, or lead hip force, which would create rotational acceleration of the pelvis. So that's something we want to work on. And as a result, because of the dynamic of throwing, extending the elbow, upper body dominated power process, and some knee extension, we see posture is not what we would expect it to be. Very upright to begin with at foot contact, and then forward flexing. So we would expect to see a little bit more extension than into forward flex, but the forward flex is pretty decent. However, we have quite a bit of lateral bend right off the bat, and that's as a function of the hips not accelerating. The hips are kind of stuck. So as a result, because the hips are opening, we stay in a lot of lateral bend. So the forward flexion posture is pretty good. If you look at him as he goes to release, that's pretty good right there. But he's quite a bit left bent, and that's crunching the spine and really keeping him from using his core effectively. And that's mostly a function of lower body mechanics more than it is actual core strength. Muscular loading at the core is pretty limited, and that's because it's upper body dominated. We would expect to see the lower body accelerate, then the upper body. We see the upper body accelerate first, so there's not very effective core muscular loading or core utilization. Arm dynamic is also a little bit of an issue. when we look at the elbow extension, what we're looking at here, what we typically want to see is core load, elbow load, shoulder load. And what we're seeing is core and elbow load happen very early. And so if we come back here, you can see he's in pretty good position here as his foot comes into contact with the ground. But what's interesting is if you come back here, just look at the video, his foot isn't even in contact with the ground yet, and he's already accelerating his upper body. His foot's not even in contact with the ground. Now here's where his foot is going to make good contact with the ground, and he's way, way ahead of the game as far as rotating and extending the elbow. So he's really like stretching across the chest a lot and really not loading the shoulder very effectively. So that's really interesting that you can actually see so much upper body movement. You can see he's not even in contact with the ground yet. His upper body, his lower body's not moving at all, but his upper body is rotating like crazy. He's losing the elbow angle. So he's starting already to extend the elbow. He's going to here bend the elbow a little bit. That's what we're seeing in this action. And then a rapid extension of the elbow, almost flinging the ball from elbow extension. So arm load dynamic, upper torso, very upper torso dominated, arm load dynamic, not that good, and really costing him efficiency, control, consistency, and also really increasing the stress load on the shoulder and the arm. And then with respect to delivery, when you look at the delivery of the speed, the delivery is pretty effective overall in terms of utilization of peak speed and the direction of peak speed. But because it's coming predominantly from elbow extension, the elbow's out quite far in front of the body, we're not using the legs very effectively, arm speed isn't going to translate as effectively into ball velocity. So a lot of wasted speed being generated. So if we can improve lower body utilization, improve core loading and core control, improve this overall sequence, take the upper body out of that dominant position, let the legs drive the process, create a better arm load dynamic, then we're going to see much more bang for our buck in terms of speed generation and ball velocity, the relationship there. And then we're also going to see the stress loads come down off the shoulder and the medial elbow.